Ni kalau mu nak berhenti mu.
Hello everyone. Today we're going to learn about limits and continuity. And I am using a new method to improve my lecturing, and I hope all of you will benefit from this. And please let me know if you have any problem to access this lecture note, or if you have any problem to listen, if you have any audio or visual problem in accessing these notes. Okay guys. Okay, in this chapter we're going to learn about the definition of limits, one-sided limits, limits law, infinite limit of a function and at asymptotes, limits at infinity and its asymptotes, L'Hospital rule, and continuity of a function. I will probably segregate this chapter into two parts. So for today, I will try my best to finish the first part of this chapter. Okay. The definition of a limit is that suppose the function f is defined for all x near a except exactly at a. If fx is arbitrarily close to L, for all x sufficiently close but not equal to a, we write like this. Okay, so for example, example 1, find f1. Okay, how to find it? Okay, let's try it here. Okay, replace x with 1, and then you will get 0/0, which is undefined. So the answer is undefined. Okay, and then however, for B, let's see, can we find the limit for f1? The answer is undefined because it is 0/0. So let's see, this is B. So fx here is x square minus 1 can also be written, okay, then and then substitute x with 1 here, so then you will get 1/2. So for A, the answer is undefined, but if we try to find the limit for fx, we can get which is 1/2. So this is the definition of limit with the help of a visual aid. Okay, limit of fx as x approaches a is L. Okay, can you relate that? Limit of fx as x approaches a is L. If the values of x approach L as x approaches a. Okay, I know it's hard to understand from here. Now we're going to look at some examples. Okay, for example, a limit is what happens when you get closer and closer to a point without actually reaching it. So for example, if fx equal to 2x, then as so we write it like this. Okay, as x approaches 1, fx is 2, which can also be written like this. So from this table you can see the value here gets closer and closer to 2 without reaching it, and see how the more details value of x here, and you can get much closer to 2 here, okay, as compared to 0.9 and 0.99. So for 0.9 you can get 1.8 compared to 0.9999, and it is 1.9998, which is much closer to 2. So from here, for this function here, limit fx is equal to 2 when x approaches 1. Okay, and then here limit for fx, for the function fx here, is 4 as x approaches 3. Okay class, so from here the example asks us to find what is the limit for the function fx as x approaches 2. Okay, so and then here, then it should be 3. So the answer should be 3. Okay, now we learn about one-sided limit. One-sided limit is the positive limit, which means as x, right hand limit of fx as x approaches a is equal to L. Okay, just look at this example. So you have to remember, for right hand limit it is positive, and it comes from here, the right hand side of your hand, of course. Okay, and then for left hand limit, it comes from left, and then it is denoted by the negative sign here. Okay, this example show us the limit of fx is 3 as x approaches 2 from the right. Okay, so the limit is 3 for this function, and the limit is also 3 when as x approaches 2 from the left. So this is the right hand side, which you should remember should be synonym with positive sign, and this is the left hand side, which is denoted by the negative sign here. Okay, for this function g here, the left hand and right hand limit at 1 are defined as follow, which will resulted in the same value, which is 2. So this means the limit exists because the limit here is the same value, which we should look into further discussion here. Okay, this is the rule of limit that you must remember. Limit x approaches A is L if and only if the value of the right hand side of the limit, left hand side and the right hand side of the limit is the same value. So let's look at example 3 here. Example 3. Okay. So the question is, find the limit of x as it approaches 0. Okay, as x approaches 0, okay, so the limit for x for the right hand side is 1, and the limit from the left hand side is minus 1. Okay, so this means the limit does not exist because it is not the same value. 1. Okay, from the positive side it is 1, and from the negative side the value is minus 1. Okay, okay, now let's look at example 4 as the limit f(x) approaches 2. Can we find the limit for it? So this is example 4, and it is actually example 2 already here. So from the right hand side and the left hand side, the value is both 3. So yes, the limit is 3. Yes, the limit exists and the value is 3. Okay, let's look at the function y equal to gx here. Does limit exist for this function at x equal to 2? So at x equals to 2, so from the right hand side the value is 1. Okay, from the right hand side the value is 1, and from the left hand side the value is about 4. So does it exist? No, it does not. No, because the value is not the same. Because from the right hand side the value is 1, and from the left hand side the value is 4. Since the value is not similar, so no, the value does not exist. Okay, let's look at example 2 at x equal to 4. So from the right hand side and the left hand side the value is similar, which is 1. So yes, it did. Okay, for example 7 here, for the graph gx, find the following limit if they exist. So let's look at the first one. As x approaches 5 here, 5 here, does it exist? Yes, it does, but at the value of 0. Okay, value of 0 or 0 point something. Okay, since this is 0 here, and then let's look at the second one. As x approaches 9, so from the right hand side it is 2. The value is 2. Okay, and from the left hand side the value is 1 something. Okay, 1 point something. So no, it does not. This one, yes, it exists. And then we look at 4 here. For 4, yes, it does, because the value is kind of similar, which is almost 3. Okay, this is the limit definition summary. which and then here is the non-existence of limits and laws of limit that that might come in handy when we come across the subsequent chapter after this. Okay, for me, maths in words or in theory is a bit hard to understand, so I prefer to show it to you in a calculation, and then we try to relate it to the theory here. Okay, let's look at example 1 here. We try to solve it here. Let's see. Then just put in the value of minus 3 here. Okay, minus 27. Then you will get then 9, we should get, and you can simplify it for 1/5. Okay, so for I want you to do example B and C and submit it to me on eLearn. Whereas for example 10, if you try this needs some manipulation. If you try to let's see here, for example, we try to do this, and then 17 minus 17, and then 17 plus 8, third minus 5, and then this we get 0, and then 25, so 25, 5, 5, 5, and then okay, so this is undefined, which is not the final answer. We need to do some manipulation on the equation here, which I'm going to show it to you now. Okay, so this is for example A. And then multiply it with the conjugate of the denominator here, plus 5. So for conjugate, the sign should be reversed. Since this is minus, so this should be 5. However, the symbol inside the cert here should not be changed. Okay, and then so set x plus 8 times with 8 times 8 should get 8 plus 8, and then minus 5 times 5 should get minus 25. So here then okay, at this stage you can put in the value of 17 here. So set 25 plus 5, set 25 plus 5, so you should get 5 plus 5, and the answer is 10. Okay, now let's look at example B. So sorry, I should have just multiply with its conjugate, so I have to rewrite it here again. Just bear with me. So the conjugate is 10 plus, this is a minus sign, so the conjugate should be plus x square minus 21. Okay, this time we choose the upper denominator to be used as the conjugate instead of the lower one. Since if you use the lower one, it will result in 0 after a few steps, which I have tried. And also, if you try to directly replace the x square and x here with minus 11, it will also result in 0 over 0, which is undefined. Okay, whenever you come across a equation for limits like this, let's say the question asks you to find the limit for this equation, and you include in the value of x here, and it resulted in 0 over 0, so that means you have to resort to other method to find the value. Okay, don't just stop when the answer is 0 over 0. So no, that's not the final answer. You have to find a way to calculate it until the value is not 0 over 0. So one of the way is using conjugates here. Okay, so let's see. So this should be 100 minus x square. Okay, I hope you're familiar with this. I don't have to explain it step by step to you, but of course you can do it at home. and check whether you can get the same answer like this. Okay, 10 minus third x squared minus 21 times 10 plus third x squared minus 21. Okay, just try it at home. Then we change it here. Sorry, this is not okay, there's no square there. So then here you will get 121 minus x square. Okay, don't forget this. And then you can kembang, I don't know what is it in, you can factor it like this. Okay, okay, and then you will get this. Sorry, okay, put in the value of minus 11. Then plus and you will get 22 over 10 plus 10, which can be simplified as 11 over 10. Okay, try this at home also and see if you can get the same answer as me. So now let's look at example C. Okay, example C is pretty straightforward. X squared plus 6x minus 16 over x plus, and then we fact. What's the next step is we factor it. So either you can do conjugates, or you can factor the equation, whichever way is feasible. Okay, this might seem hard, but if you are familiar with the way how things work, then you will know what to do. Okay, and then just minus 8 minus 2, and you get minus 10. Okay, easy peasy. Okay, that's all for today class. And if you have any problem in understanding the lecture note, you can always PM me. Okay, bye.